Hi everyone, my name is Israel. I'm a front-end developer at Premium, and today the talk is about Redux history. Initially, when I created this talk, I called it the evolution of UI architecture. I started with a research about MVC, Flux, and Redux. And I realized that there is a certain connection, a relationship between the three of them that I wasn't aware of before. And this connection is the very foundation or the history, the origins of Redux as we know it today. And I also found out that maybe, just maybe, the design pattern behind Redux is not a new concept or a new pattern as we all know it as Flux today. So I decided to dedicate the entire session today to explaining the relationship between MVC, Flux, and Redux, and talking a little bit about the design pattern behind it. So today's agenda is to explain this relationship, to talk a little bit about the alternatives that were before Redux, and we cannot talk about Redux without mentioning bidirectional and unidirectional data flows. So let's start with some of the very ancient, maybe the first UI architecture out there, and I'm talking about MVC. In 1979, way before Redux, Angular, or even HTML was even created, Trivich Rinskog introduced to the world the MVC pattern. And what is MVC? Basically, MVC is a software architectural pattern that separates the application into three parts: model, view, and controller. In other words, MVC is just a design pattern for managing UI applications. And how does it look like? We have here an example, a diagram example of an ATM machine. We have here the view that is responsible for managing the UI application, or in other words, rendering the model, the presentation of the model. We have the controller, that this is basically the logic of the application, and we have the data of the model. This is the model. And how does it work? If a user or someone clicked on the deposit button, event is sent to the controller. The controller takes this event and decide what to do with it. In our case, the controller will decide to update the model data. So it sends a notification to the data or changing it immediately. And the balance in our case is changed from 0 to 10. Next thing, the model takes this data and notifies the view that the data has changed. The view takes this data and renders to the screen the new data. In our case, the balance is changed from 0 to 10. And this is the simple explanation and the simple pattern of MVC. Even Facebook used this pattern in their applications. In one of the conferences, Facebook said that the entire chat application is built around the MVC pattern. You can see here that we have the small area chat, the big area chat view, and the toolbar that explains how much messages we are still having. So even Facebook, a large application like Facebook, uses this pattern. But something has changed. In 2014, Facebook announced that MVC does not work for them anymore. And they're going to change their architecture, their inner architecture. According to Facebook, MVC has one major disadvantage, and is that MVC doesn't scale. Basically, what Facebook is saying is that MVC is based on the concept of bidirectional data flow, or in other words, two-way data binding. And therefore, MVC doesn't scale. And let's try to explain this, what this bidirectional data flow means and why it doesn't scale. Bidirectional data flow refers to data being changed in multiple directions. Basically, in MVC, it means that the model and view can change each other. I want you to think about the model and view as just pure classes. And bidirectional data flow means that the model class has access to the view instance, and the view class has access to the model instance, and they can change each other. And this flow of data in bidirectional data flow, it's very hard to detect changes or to know who changed who and in which direction. In Angular and Vue framework, if you work with them in AngularJS, there is this terms of ng model or v model, and they basically mean that if data has changed in one place, it will automatically reflect in the other end. And basically, what is the problem with that? The problem with that, as you can see in the diagram, is in 2 words, spaghetti code. Basically, Facebook had a spaghetti code in their application. And because of the spaghetti code, they didn't know if they have infinite loops or which edge cases can cause a problem to them. And this is not just a theoretical problem. Facebook had this problem in their chat application. They had this feature of the unseen counter. We all know it, like the messages icon with the red counter above that's saying how many unread threads we have. So how it's all started. Facebook developed initially the small chat area. After that, they added the toolbar with the messages and the unseen counter that says how many messages you still have that you didn't read yet. And finally, they created the larger chat area, which we're all familiar today from the web. And they had this annoying bug where the unseen counter show unread messages, but when you enter it, you saw that you actually read all your messages. And the design behind this thing was very familiar. It was a design like that, a spaghetti code. And every time they added a new feature, the bug is returned. They fixed the bug, but it returned in another way, in an edge case. And this is the reason Facebook decided that they cannot use anymore MVC because of its bidirectional data flow, because it's hard to detect changes and to understand what is happening. So they decided that this is the time for a new architecture. A large scale application like Facebook cannot use MVC anymore. So what Facebook did, they created Flux, an alternative to MVC. In 2014, during the same session, during the same conference that Facebook said that they cannot use MVC anymore, they announced the Flux architecture, a counterverse to MVC. And the main concept of Flux is to be unidirectional data flow, as opposite to MVC that is bidirectional data flow. And Facebook moved all their application to use the new architecture of Flux. And this is the diagram that they have presented. As you can see here, the data flows in one way, to the right, and in a circular way, only in a singular direction. And how does it look like? The view sends action to the dispatcher sends action to the store, and the store updates the view again. And we will explain those terms in a second, but I want you to look at it again. The data flows only in one way, in a very predictable, deterministic way. Just like MVC, but the opposite here is that the data cannot be changed in a multiple direction. The store are not familiar. The view is not familiar. The store cannot change the view directly. It just sends an event to the view, and the view takes this event and changes itself. So let's explain what every node here is doing. And we'll start with the action. So what's our action in Flux? Actions are basically the interface, the internal API of the application. They're just objects that define what we can do in our application. Let's say an example that we have a to-do application. We can have an action of add to do and an action of delete to do. And the action is just object with a property that describes what is this action and a payload. This is it, a very simple object. The dispatcher is the event emitter that takes this object, takes this action, and fires them, emit them to whoever listens to it. It's a very simple event emitter. That's it. In our case, the store will register to the dispatcher. The dispatcher will emit events, emit the action, and the store will get this action. The store is just a data store. Basically, it can be a class, a function that manipulates some data. The only rule is that the data in the store, the data that the store manages, can change only using an action, meaning only if action came to the store, the data can be mutated. So the store is registering to the dispatcher events. When dispatcher emits events to the store takes the action, decides what to do with it, and if he wants, he mutate the data and change it. And then when it's done, he's notifying all the views with the new changes. Or in other words, whoever will register to the store will get the new changes. And as you may guess, the view is registering to the store, taking the new data or the changed data, and render itself. After the view render itself, he might trigger more action like some event was click or add to do in our case, or delete to do, and the cycle goes on and on again and again. So basically the action go through the dispatcher to the store notifies the view, and the view can trigger other actions as well. So using this architecture, as we can see, we define here a unidirectional data flow, a very simple, understandable data flow. And this is the architecture Facebook used to create their new chat application, and the bug has disappeared. It was great, and the year was 2014, but a year after, Dan Abramov wanted to create a new library. He wanted to create much more strong library like from the other Flux implementations that were in this time. So basically, even Facebook created a library for Flux for the architecture, but then wasn't satisfied with that. Then created a new library called Redux, that the architecture of Redux is the same as Flux architecture, because Redux is just a library. It's just an implementation of Flux. And basically the data flow and the diagram are very similar, or maybe I can say identical to what Flux showed us, because they are the same architecture, just different implementation. And the main change of Redux over the most common Flux implementations were those three changes: a single source of truth, immutability, and that the implementation of store is a reducer function. And I will explain. A single source of truth means that in the Flux diagram that we saw earlier, there was a store that stores all the data, but basically there might be multiple stores like user stores or to-do stores or task stores. No one told in the Flux architecture that there must be only one store. The data flow stays the same, by the way. If I had here multiple stores, the data flow is still in one way, in one direction, to the right and in a circular way. But Dan decided that you can combine all your stores together in a single store, like you have in components. You have a root component that defined all other components, like all other components are getting just after the root component. So we decided that it will be a good idea to have a root store. And this is actually a very powerful technique or feature or idea, because now we have a single source of truth. All our data sits in one place. Another thing that Redux enables is the data manipulation is immutable. Using that technique, meaning if you want to change the data in the store, you must create a new instance, a new reference. You cannot mutate directly the data. For example, if you have an array of to-dos, you will return for add to do or delete to do a new array, and you will not mutate the existing array. Using this feature, then could introduce some very exciting other possibilities and other dev tools for debugging and other possibilities that were very hard or impossible to create with the current Flux implementation. And the last thing that Dan says is that the store in Flux architecture reminds him very much of the reduce function, of the JavaScript reduce function. The JavaScript reduce function takes as an argument the accumulator, the current action, and the accumulator, the current variable, and returns the new accumulator. In our example, it's very similar to what the store does. It takes the current state, it takes an action and returning a new state. So it's very similar to the idea of reduce. We have the state that this is the accumulator. We have the action that this is the next operation, the next variable of what we need to do, and we are having some logic on top of it, and we are returning a new state. So they decided that every store is basically a reducer function, and the combination of all the reducer functions are basically the store itself. And this is also a very powerful thing in Redux. And I wrote here when Redux has introduced, it was the differences, but today, even the Flux implementation already have reducer store implementation, because there are some powerful things that you can do when you think of store as a reducer. Some other alternatives that were before Redux are Flux and Fluxmux, but they are both today are in maintenance mode. Basically, the author says that you don't need to use them anymore. You can use Redux or other state management libraries, because all of the features that Flux and Fluxmux has, the libraries are already presented in the Redux implementation. And when the community asked why use Redux over Facebook's Flux, Dan Abramov answered, basically, Redux is not so different from Flux. Overall, it has the same architecture, right? Because Redux is just a library, it's just an implementation of Flux. But Redux is able to cut some complicity concerns based on functional composition where Flux uses callback registration. Basically, in Redux, the reducer function and all the stores are reducer functions that can be composite together. And in Flux, you needed to register the callbacks and emit changes after some changes awkward. It was a very complex idea. If you think that today Redux has some boilerplate, you need to see how Flux was before. And basically, this was the alternative. This was the history of Redux. But we are not done yet. I want to take you some slides before when you talk about Facebook and MVC. And if you remember, it all started from MVC. Facebook used MVC, and they say that MVC doesn't scale, and therefore they created Flux. And they presented this diagram, the diagram of the spaghetti code, where the view can update the model can change the view, and this caused them lots of problems. But this doesn't look like the original MVC pattern. It doesn't look like the simple MVC pattern. Now, who said that the view can change the model? Who said that the model can change the view? Now, the model can change the view, can notify the view of the changes, because this is the MVC pattern, but not vice versa, not the opposite way. So how can Facebook say that MVC doesn't scale when they don't use MVC? It's some other kind of diagram. I don't know which one. And the community started to ask those questions. And I gathered here some of the things that the community says. For example, MVC done incorrectly doesn't scale, so we replace it with MVC done correctly and gave it a cooler name. Woo. So basically, for some people, in some opinion, Flux is just another variant of MVC. And there are much other variants like MVVM or MVP, and Flux is just another variant of MVC, or maybe the original pattern itself with a different name, right? And this is the response of Jin Chen. Jin Chen was the developer who presented in Facebook conferences the Flux architecture. And she said that, yes, this slide was a bit tricky, and she's talking about the slide with the MVC diagram, partially because there is not a lot of consensus for what MVC is exactly. Lots of people have different ideas about what it is. What we're really arguing against is bidirectional data flow, where one change can loop back and have cascading effects. Basically, what Jin Chen said is that MVC, if you look at the web, many people have many ideas, have different ideas of what MVC is. Some of them explain MVC as MVVM. If you will open a 10 different explanation, there are probably 9 different explanations of what MVC is. In this presentation, I try to go very back to the first creation of MVC in the Smalltalk programming language to understand what was the initial creation of MVC. And actually, the initial pattern, the design pattern of MVC is, in its idea of unidirectional data flow, is the same as Flux. So basically what Jin Chen said here is that they are arguing against bidirectional data flow and not against MVC. So about our first question that we said, that maybe Redux design pattern, the design pattern behind Redux was there all along. Some people will say that we're actually still using the design pattern MVC from 1979 because nothing has changed. Some different naming, but the idea is the same. So we are still using the same architecture 40 years after. And this is the history of Redux, the pattern behind Redux. Some final thoughts, right? We talked about the history and theoretical stuff, but in the end, should you use Redux in your application, in your day-to-day application? So basically, the Redux team said that you need one of those three reasons to become. So you can say that you need to use Redux in your application. Basically, if you have a reasonable amount of data changing over time, you should use Redux. It can manage these data changes. If you need a single source of truth for your state, or if you find it hard to keep all your state in the top level component, or basically manage it yourself. And in my perspective, as one that uses Redux almost in all of its applications, if you are creating a project, a new project, especially in the work, you probably will run with this project for at least a year, maybe two, I don't know. Because if not, it's just a POC or small project, yeah. If it's small project, you don't need Redux. But basically, if you're starting a new project and you're saying, okay, if the time will come and I have lots of data, I will use Redux, I can promise you it will be a little bit more complicated from starting with Redux in the first place. And it's not cost much. So I very recommending to use Redux from the beginning. And this is it. My name is Israel. If you have questions, please. Thank you.